IIT JAM. So from this video I will be uploading series of videos which is related to IIT JAM Physics, and particularly I will be solving previous year problems. On that time simultaneously I will be discussing some solution techniques, how you can solve the problems, because once you discuss all the topics step by steps, that will take time. So what we do is we will try to solve some PYQs, and we will try to understand how to solve the differential equation. I assume that you know some basic differential equations, how to solve basic differential equation, first order, second order differential equation. And if you have any doubt, try to discuss in the comment section, and if you have any queries to address, you just discuss that on the comments, okay, comment section. Or further, if you want to contact us, so we can follow our channel, we can get the doubts there, right? So let's get into the first problem. Okay, so we have a function here, okay, where x is equal to 80 and y is equal to bt. So the value of df by dt at t is equal to 0. So they gave they given the function f of x comma y. Okay, so then give x is equal to 80 and y is equal to bt. So what we do, x is equal to 80 divided by a e, and y is nothing but bt, plus y is equal to bt divided by b e power 80. Let's try to cancel certain common things. So numerator and denominator. So this is nothing but t e power bt plus t e power 80. Okay, so we have to find for df by dt. You know, t is the independent variable and f is the dependent variable. Even though function depends on is a function of x comma y, okay, we are differentiating with respect to t. Okay, so that thing you have to keep it in mind, right? So let's start differentiating this. E power, we have e power. First we are differentiating with respect to t, then t will become 1, so we have e power bt plus t b e power bt. Here we are applying uv formula here. Similarly for second one, e power 80 plus t a e power 80. Okay, so they asked for at t is equal to 0. At t equal to 0, what happens? This will become 0, again this will become 0. We will be having e power 0 and plus e power 0. So this will become 0 and this will become 0. Anything power 0 will be 1. So 1 plus 1, which is equal to 2. So answer is option 2. Okay, right. This is the simple problem. Okay, again it's IIT JAM problem. Okay, in differential equation. Right. So next. So it's a fill in the blanks question. You have to give the numerical input. Okay, so numerical input. So, and one more thing you have to keep it in mind. So there will be on-screen calculator. Okay, in your JAM examination, because if you want to do any calculation or if you have to get any numericals, you can use that on-screen calculator. Right. So here we have a differential equation. It's an ordinary differential equation. 4y prime plus 5y equal to 0. Let's write this in a form of a quadratic equation. As you know, this is how we solve the second order differential equation. Once you solve this quadratic equation, you'll be getting two roots. Depending upon the type of roots, we'll be writing the general format of a general solution, right? So we can use m is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So minus b is nothing but, so this the quadratic equation has a general format, ax square plus bx plus c is equal to 0. So in this case, instead of x, we will be having m here. Okay, so here a is equal to 1, b is equal to 4, and c is equal to 5 here. Okay, so minus 4 plus or minus b square is nothing but 16 minus 20 divided by 2a. So remember, this is how we used to solve, but you don't need to do all these procedures. Okay, once you see the equation, if you are able to find the root, okay, then you can use that root directly. Okay, so here we have minus 4 plus or minus. Here you can see we have minus 4 inside the square root, so you will be getting a complex root here. Okay, so once you solve for it, you will be getting minus 2 plus or minus I. Once we have a complex root, okay, once we have a complex root, we will be using a format of a solution of a differential equation is e power alpha x into a cos beta x plus b sine beta x. So the complex roots, which is nothing but alpha plus I beta, here alpha is 2 and beta is 1 here. Okay, so I can write y is equal to e power minus 2x and a cos x plus b sine x. Okay, because beta is equal to 1. So from the format of a differential equation. Okay, now we are having two initial conditions. Okay, now to fix the values of a and b. Okay, so let's find for y of 0, which is let me write. If I put sine 0, this will become 0. So e power 0, again it will become 1 here, and we have a cos 0 will become 1, and which is equal to 0. So we come to the conclusion that one of the constant a is equal to 0. Okay, so once I fix this, okay, so what I have to do is I have to rewrite this solution by on applying this first initial condition and write it as y is equal to, since a is equal to 0, I can leave this term. Okay, I can write it as e power minus 2x into b sine x. Okay, let's try this. Okay, I can rewrite this as b e power minus 2x sine x. So once I take a derivative, okay, because we have to apply y prime of 0 here, so let me take the derivative here. So y prime of x is equal to minus 2b e power minus 2x sine x plus b e power minus 2x. So once I differentiate sine x, we will be getting cos x. Okay. Now let us apply this condition here. So we have a second initial condition. So y prime of 0 and y prime of 0. So if I put 0 in this term, this will become this term will vanish. So we have b equal to 1. So we got the values of a and b, and let's substitute that in this equation. So once we have the values of a and b, let's do this. Y is equal to e power minus 2x, that is from this term. Okay, from this equation we write y is equal to e power minus 2x. So a is 0, so we don't need to write this one. Okay, so we need to write sine x. Okay, so sine x, once you write sine x, what will happen? We have e power minus 2 is there, then we have pi by 2 instead of x. We have to, yeah, we are applying this one. Okay, pi by 2 and sine pi by 2. So this will become, so if you estimate the value of e power minus 5, then you will be getting 0.0432. Okay, so answer is 0.0432. So this is the answer. Okay, so if we are giving the numerical inputs, so at least you have to make sure that 3 inputs are up to 3 decimals. Okay, so this is the correct answer, right? So once we have an initial condition, we are finding the particular solution for this second order differential equation, right? Okay, let's get into the next problem. Right, so the solution y of x of a differential equation this is the first order differential equation, y into dy by dx plus 3x is equal to 0. Then y of 1 is equal to 0 is described by what? Whether it's an ellipse, the solutions can be described by any one of this general equation. Okay, right. So let's write. So y dy by dx plus 3x is equal to 0. So let's write y dy plus 3x dx, okay, and this is equal to 0. Once you integrate this, you will be getting y squared by 2 plus 3x squared by 2, and we'll be getting some integration constant. That 0 will become some constant here. Okay, so if I make it as if I divide all these terms by 3, so I can write x square by 6 plus y square by x square by 3 here, because this 3 and this 3 will vanish. So we have y cube by 6 is equal to c by 3. So what is this? So x square plus y square, and we have different values of a and b here. So here's an equation of an ellipse. Okay, right. So the correct answer is obviously. So okay, this is the semi-major axis and semi-minor. So if these inputs are same, these things are same, then it will end up as a circle, right? And if a function f of x is described by the initial value problem, we have d square y by dx squared plus 5 dy by dx plus 6y is equal to 0. But the initial condition y of 0 is equal to 2 and y dash, which is the first derivative of the solution, at x is equal to 0 is equal to 0. We have to find the solution of y at x is equal to 0. Okay, so this is again it's an easy problem. This is of the same type, because it is always better to choose the numerical inputs problems. So we don't have any there is no negative marks for this kind of questions, even in IIT JAM or GATE, right? So let's get into this problem. Okay, so we have y double dash plus y dash plus 6y equal to 0. Okay, so let's write for, so see, you don't need to write all these steps. Okay, so once you know this is a differential equation, you can straight away write the quadratic equation like this: m squared plus 5y plus 6 is equal to, if you know this is, here we have 1, b is equal to 5, c is equal to 3, you can straight away write minus 5 plus or minus square root of b square is nothing but 25 minus 4, a is 1 and c is 6. Okay, you can straight away write those things. Okay, you don't need to stick with all the step-by-step process, because if you stick with all this step-by-step process, it will consume a lot of time. Okay, so you should be very familiar with certain mathematical procedures, and once you see the equation, you are able to write the solution, because these things can be achieved with the help of factorizations also. Okay, so they won't give any complicated numbers. Okay, once you see, you are able to write the factors like that. Okay, right. So here we have minus 5 plus or minus 1 divided by 2. So it will be having minus 6 by 2 and minus 4 by 2. So which is nothing but minus 3 and minus 2. So these are the roots. See, the roots are real and distinct roots. So if we have real and distinct roots, what we have to do, we have a general format: y is equal to a e power m1x plus b e power m2x. Let's assume this is m1 and this is m2. So let me put this is m1 and this is m2. You can use interchangeably, it doesn't matter. Okay, so we have a e power minus 2x plus b e power minus 3x. Okay, so once we have general solution, we will try to apply the initial conditions here. So we have y of 0, which is nothing but a plus b, which is equal to Then we have to find the derivative. So y prime of 0. So once you take a derivative for this, so you will be getting minus 2 a e power minus 2x minus 3b e power minus 3x, right? So this is y prime of x. Let's apply the condition here. Y prime of 0 and it is equal to minus 2a and minus 3b equal to 0. So we have equation number 1 here, which is a plus b equal to 2, and here we have minus 2a minus 3b equal to 0. Okay, so this is one equation and this is another equation. So we have two equations and two unknowns. So we have, let me write this minus 2a minus 3b equal to 0. You can write again 2a plus 2b equal to 4. Right. I am just multiplying this into 2 and I am writing this equation. Right. Let me cancel this. Then I will be getting minus b equal to 4 and b is equal to minus 4 from this equation. And once we have b is equal to minus 4, a plus b is equal to 2 and a is equal to 2 plus 4, which is equal to 6. So a is equal to 6. So let me write the particular solution here. Y is equal to a is nothing but 6 e power minus 2x plus we have minus 4 e power minus 3x. We have to find for y at x is equal to 1. So let me write it 6 e power minus 2 minus 4 and we have e power minus 3. So for this you can use your calculator in your on screen. So 8120 minus 0.19914, then you will be getting 0.6128. Okay, so this is how we have to solve these kind of initial value problems. Okay, right. Let me come back to that problem later. And again, here we have another differential equation which is of same kind, okay, but the roots are quite different. Here you will be getting same roots while solving the differential equation, and we have a general format for that. So in this video we discussed three types of solution for a second order differential equation, particularly by finding the roots, right? Okay, let's solve for this, right? So just a minute. So we have, say this is, here we have 1 and this is 2, and so this is a, this is b, and this is c. C also will be having 1. So minus b minus 2 plus or minus square root of b square is 4 minus 4ac. 4, a is 1 and b, c is also 1 and divided by 2. So what happens? So minus 2 divided by 2 and this term becomes 0. So it will be having minus 1 as a single root. So we have only one root. Okay, so if we have roots like this, okay, then you can write a general solution for a second order differential equation as y is equal to a plus bx plus e power minus 1x. So this is what the root which we found from solving this quadratic equation. So I can expand this and write a e power minus x plus bx e power minus x. Okay, so we know y of 0 which is equal to a plus 0, because if I substitute x is equal to 0, this term will become 0 and this is equal to 0. A is equal to 0 from this condition. First initial condition, we can establish that a is equal to 0. Then we have to find for y prime, that is y, first derivative of y. So we can write minus a e power minus x plus b e power minus x minus b x e power minus x. So here we used the uv formula here. You have to remember what is the uv formula is, right? Then y prime of 0, so this will become 0. Okay, so we will be having minus a plus b equal to 1, and from this condition you came across the value that a is equal to 0, so we will be ending up at b is equal to 1, right? So then we can write the particular solution, that is the solution after applying the initial conditions. Okay, so y is equal to